Hello, algebra students. We're wrapping up Chapter 10. Our last section in Chapter 10 is about trigonometry. Trigonometry is the study of the relationship of the sides and angles of a right triangle. So there again, it's that exclusive club, just like Pythagorean theorem. It's for right triangles only. And we're going to be talking about trigonometric ratios, which is the ratio of the sides of a triangle. So in this first little chart, here are our trigonometric ratios. Sine of angle A. So if you are standing here on angle A, I hope by now everyone knows that C is our hypotenuse. So if I'm standing at A, looking opposite of me, A would be opposite here. And so B, I'm adjacent to the hypotenuse, but I'm also adjacent to this leg. And so the hypotenuse always gets that special, funny little name, hypotenuse. And then you have to determine, as we're dealing with trigonometric ratios, which angle am I standing on? Am I looking for angle A or am I looking for angle B? For these examples, they're talking about angle A. So from A, opposite is the side called A, and adjacent is the side called B. So sine is always opposite over the hypotenuse. That's the ratio. So you'll notice they said here the sine of A is A, little a, the opposite side, over C, which is the hypotenuse. The cosine is the adjacent leg. The adjacent leg is B, so the adjacent leg over the hypotenuse. So B over C. And then the ratio for the tangent of angle A is the opposite leg over the adjacent leg. There are three ways, different little mnemonics people use to remember sine, cosine, and tangent. My favorite one is Native American Chief Sokotoa. This is Chief Sokotoa here. Chief Sokotoa had three sons: sine, cosine, and tangent. Okay? And Chief Sokotoa, sine, the ratio is always opposite over hypotenuse. That's OAH. Ka, that's cosine. Cosine, but we remember ka is adjacent leg over hypotenuse. And I can't write and talk today. Okay, and then koa is the tangent, which is opposite leg over adjacent leg. So Chief Sokotoa, sine opposite over hypotenuse, right here. Cosine over adjacent, ka, and then toa is tangent, is opposite over adjacent. So that's my favorite way to remember it. I also have heard silly old Hitler helps you remember the SOH, silly old Hitler. CAH caused awful headaches, and then TOA, TOA, to our airmen. Some people like Oscar had a heap of apples. That one I'm not as familiar with, but whatever works for you so that you can remember how to set up your ratios. All right, to the next page. So I always write SOKOTOA at the top of my page. You can either write it SOKOTOA, or a lot of people, to help them remember that it's a ratio, the OH sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So we're going to look at some examples to help you be able to identify adjacent, and of course hopefully everybody can identify hypotenuse, and to identify opposite. So these are the actual ratios: opposite over hypotenuse, so adjacent over hypotenuse, ka, and toa, opposite over adjacent. So when I go to this first example, the first thing I need to do is to identify what angle I'm looking for. So angle B, that's where I'm going to stand. If I'm standing on angle B, then I'm going to identify always the hypotenuse is opposite the right angle. Opposite of angle B is 12, and then adjacent is the leg, they've named it B. So that's what I'm dealing with in the first example. So to set up all of our ratios, the sine of angle B equals, that's so, OH, opposite over hypotenuse. The cosine of angle B equals, that's chi, adjacent, which I don't know what B is, over hypotenuse. And then the tangent of angle B, TOA, opposite over adjacent, would be 12 over B. Now, using Pythagorean theorem, I could find out what B is and be able to then fill in my variable. So let's use Pythagorean theorem quickly. Over to the left, B squared plus 12 squared. Whoops. Okay, so B squared plus 12 squared equals 13 squared. When we do our math, we're taking the square root of 25. Normally, under algebra circumstances, we would say plus or minus 5, but this is a geometry, actually a trigonometry problem. So we know we're talking about the length of a triangle. So we could replace that with 5 over 13 for cosine and 12 over 5 for tangent. I might should have found B before I set it up. So let's not make that same mistake twice. And on example 2, let's go ahead and find our missing side. So B, so our leg B turns out to be 15. All right. And we're looking at angle A. So let's get our little person and stand on angle A. Now let's identify all of our sides. 17 is our hypotenuse. If I'm standing at A, 15 is beside me, so that's adjacent. And then opposite of angle A is 8. So as we get ready to do the sine of A, the cosine of A, and the tangent of A, we're going to talk about so, ka, toa. So, opposite over hypotenuse, 8 over 17. Ka, adjacent over hypotenuse, 15 over 17. And then toa, opposite over adjacent, would be 8 over 15. And that's how we would set up those ratios. I'm going to leave 3 and 4 for you to try on your own. Please be sure you do that, so when I check your notes tomorrow, those will have been attempted. Again, we're just setting up the ratio in 3 and 4. Let's talk about how we're going to use our calculator. The first thing you need to do is make sure your calculator mode is in degrees. Mine was not, and I got a negative answer. So you go to mode up there beside the second button, and you'll scroll down the third row where it says radian or degree, and be sure that degree is highlighted, and then we're ready to go. Now when you hit tan of 52, first one asks us to find the tangent of 52 degrees. Again, it needs to be in degrees to the nearest 10,000th. So when you hit the tan button, here it is located here on your calculator, of 52, go ahead and get in the habit of closing your parentheses. Then hit enter and you get 1.2799. It wants to the 10,000th, so that's to the 4th decimal place. Okay, next page. Go through and practice each one of these, and again, be sure you're closing your parentheses. When you hit the sign button, it automatically opens the parentheses, but just get in the habit of closing the parentheses, and we're going to 4 decimal places, the 10,000th place. And I'm going to go through and fill in the answers. So you pause the video here, use your calculator, and then check your answers with mine. Okay, pause it again and check yours against mine. And after you've paused and checked, we're moving on to Alright, it wants us to solve the right triangle and find all side lengths and all angle measures, and we're going to round each side to the nearest tenth. So I can't use Pythagorean theorem because I have 2 missing sides. This is my hypotenuse, I don't know what it is, and I also do not know the leg A. But I have the 62 degrees and the 90 degrees, so 180 total degrees means that this angle must be 28 degrees, because 28 and 62 make 90, and 90 and 90 would make 180. Now I'm ready to use my trig ratios, my chief so, ka, toa, and I'm going to stand at the corner that they gave me. Since they gave me the 62 degrees, just in case I made a careless error, I don't want to use the 28-degree angle. Let's always use the angle that they gave us. So if I'm standing at 62, this is my hypotenuse, my H. Opposite for the O here is 14, and adjacent, my A, is going to be the unknown side, A. So I can use the sine of 62 degrees equals opposite, which is 14, over hypotenuse, which is the value of C that I do not know. Now this is where using your calculator and closing those parentheses is going to become very important. The sine of 62 degrees, we're going to cross multiply times C equals 14. So I'm actually going to be dividing 14 by the sine of 62 degrees. And that way the sine of 62 degrees will cancel. So when you punch your calculator, 14 divided by the sine of 62, C there is approximately 15 point, it said round to the nearest tenth, so 15.86 would be the approximate value of C. Now we are supposed to find all missing angles and lengths. So that means I also need to find side A. I have two choices. I could use Pythagorean theorem, which works great, or I can now use the tangent of 62. Let's practice using our trig ratio. The tangent of 62, TOA, equals opposite, which is 14, over adjacent, which is called A. So TOA, opposite was 14 over adjacent, which was A. Cross multiply. The tangent of 62 times A equals 14. Divide both sides by the tangent of 62. So now we're ready to punch our calculator. 14 divided by, this time, the tangent of 62, close those parentheses for good habits, and A is approximately 7.44. I just realized I rounded to the nearest hundredth instead of the nearest tenth, so 15.9 is a better approximation for C, and 7.4 is a great approximation for A. So now we found C, we found A, and we found our missing angle. We are finished with this problem. By the way, if you want to take the time to do Pythagorean theorem, you will get 7.4, no matter whether you used tangent, cosine, sine, or Pythagorean theorem. I'm going to have to leave number 2 for you because I'm running out of time. So do number 2 on your own. Okay, I'm going to let you read this problem on your own. The number 1 question I'm going to hear you ask is, how do you know whether to use sine, cosine, or tangent? For this problem, they asked us to find the height, h, and they gave us the 15 degrees. So the two things that I know is 15 degrees and hypotenuse, and the one thing I'm looking for is opposite. So opposite and hypotenuse goes with sine, so I'm going to be using the sine of 15 degrees. Set up my ratio. Opposite is h, hypotenuse is 18. So now I'm ready to use my calculator, and I can punch the sine of 15, close those parentheses, times 18, and that's going to give me h. Practice using your calculator too and see if you get about 4.7. Do number 2 on your own. Again, you'll use sine because of opposite and hypotenuse. Okay, we're going to use our second button to find the inverse sine, the inverse cosine, and the inverse tangent. And we use this when we are looking for the angle. So if you practice using your calculator and you punch in the sine of 40, you 0.6427. Now practice using your second button and do the inverse sine of 0.6427, and vice versa, you should end up with 40 degrees, or approximately 40 degrees. So again, practice using cosine and then second cosine so that you see the little inverse -1 up beside your cosine of 0.7660, and you should come up with 40. So practice this on your calculator. If you need to pause and look at my work, please do, but I have labeled, I'm looking for angle L, and I've labeled my parts. I have adjacent, I have hypotenuse, so I'm going to pick K. The cosine of L is 23 over 30. That's 0.7667, but I'm looking for the angle, so that means I need to use the inverse cosine. Practice and see if you come up with about 40 also. That leaves 50 degrees to be. I'm going to use so for number 3 because they gave me opposite and hypotenuse. So when I set up that ratio, I get 0.9167. I'm looking for the inverse sine of 0.9167 approximately, which out of 180 leaves 24.